Hello and welcome. Today, what we're going to be discussing in this video is an introduction to chemistry. So what we'll be talking about are elements, atoms, and how these different atoms can be held together with various types of bonds. So, let's go ahead and delve into the wonderful joy that is chemistry. Let's get started. The first thing we're going to go ahead and discuss are elements. Now, elements are the fundamental forms of matter, and each only has one type of atom that corresponds with it. So for example, there's only one type of atom that corresponds with the element carbon, or oxygen. And these cannot be broken down into simpler parts and keep their unique properties. So like we said, you couldn't go ahead and break down an atom of carbon and have it still be carbon. And finally, there are currently 92 elements that occur naturally on Earth. So if you've ever seen a periodic table, I'm sure you've seen these different elements. But there's a lot more than 92, but only 92 actually occur naturally on the Earth. So speaking of the elements, the most common elements in organic molecules can be summarized with CHNOPS, C-H-N-O-P-S, and that stands for carbon, which is the most abundant element inside the human body, hydrogen, nitrogen, which is the most abundant up in the atmosphere, oxygen, phosphorus, sulfur, and there are also some trace amounts of calcium and potassium. Now, we talked earlier a little bit about atoms. So what exactly are atoms? So atoms are the smallest particles that can retain the properties of an element. And these atoms are made up of subatomic particles. We have protons, which have a positive charge and are found inside the nucleus. We have electrons, which are found outside the nucleus, floating around, and they have a negative charge. And we have neutrons, which are found inside the nucleus as well, but these don't have any charge at all. Now the number of protons or electrons corresponds with something we call the atomic number. Whereas if you added the protons and neutrons, that would go ahead and give you your atomic mass. We'll be discussing these a little bit later once we get to atomic math. So what determines how atoms interact and bond with one another? So, what does this is the number and the arrangement of the electrons in their outermost shell. So atoms all have electrons that rotate in these kind of like shells or layers. Atoms are happy and stable when their outer layer is full. The first layer can go ahead and hold 2 electrons. The second can hold 8. So bonds, molecules, compounds, as well as a few other definitions you're going to need to know. A bond, simply put by definition, is a union between the electrons of atoms. And a diatomic molecule, so diatomic think 2, is 2 or more of the same type of atom or element bonded together. For example, H2, so 2 atoms of hydrogen, N2, 2 atoms of nitrogen, or O2, 2 atoms of oxygen. Now O2 is very important because, well, that's what we breathe. The second type are compounds. Now compounds are when you go ahead and mix 2 different types of atoms or elements. For example, H2O. You have 2 elements or 2 atoms of hydrogen and 1 of oxygen, and H2O gives us water. So the first bond we're going to talk about in depth here is ionic bonding. Ionic bonding is an exchange, so one goes ahead and donates an electron while the other accepts an electron or series of electrons. An ion is a charged atom, so if you lose an electron, so normally protons and electrons are equal or balanced, but if you go ahead and you get rid of an electron, so let's say we have 2 protons, 2 electrons. If we go ahead and get rid of that, so now we have 2 protons and only 1 electron, we have more protons than electrons, so we have a positive charge. And vice versa goes for if it is a negative charge. So if you have more electrons, so you gain an electron, you have more electrons than protons or more negative charges than positive, giving it a negative charge. So simply put, if one atom loses electrons, becoming positive, and the other atom gains these electrons, becomes negative, it's going to act like magnets. Opposites attract, so the positive and the negative will go ahead and come together, attracting the 2 to join each other. The most classic example of this is sodium chloride, where sodium goes ahead and donates an electron, chlorine accepts it, sodium is now positive, chlorine is negative, and when these 2 come together, that creates sodium chloride, or table salt. The next type is covalent bonding. Now, covalent bonding is when atoms share pairs or a pair of electrons in the outermost shell, so that way they're going ahead and meeting the requirements of both. A single covalent bond shares one pair of electrons, a double shares two, and a triple will share three pairs of electrons, or six total. Now, covalent bonds are unique because covalent bonds are very strong. Covalent bonds are incredibly hard to break apart, so if you want something to go ahead and stick together, make sure you're using a covalent. Now, before we get into the final type of bond, we must discuss polarity. So think north and south, or opposites. So, a molecule is polar when electrons are not shared equally. So, one part of the molecule will be more positive, and the other part will be more negative. So think, once again, positive and negative, north and south pole. The most classic example of this is H2O. So as you can see here, we have our two hydrogen, and we have our one oxygen. The two hydrogens have a slightly positive charge, whereas the oxygen has a slightly negative charge. So once again, one element, one molecule, a compound, we have a positive side and a negative side. Polarity. The final type of bond we're going to discuss for today is hydrogen bonding. These form between the negative atom in one polar molecule and the positive atom in another polar molecule. So normally, hydrogen is going to be the more positive, whereas oxygen will be the more negative. So the most classic example of this is the hydrogen bonding of water, or connecting water molecules to other water molecules. So as you can see here, if we label this, we have the oxygen, which is negative, we have our hydrogens, which are positive, nitrogen is negative, hydrogens are positive. So here we go, we have a positive matching up with a negative, giving us a hydrogen bond. Now, that is going to go ahead and summarize pretty much the introduction to bonding atoms and elements. So if you have any questions, please feel free to go ahead and contact your instructor. They will point you in the right direction. Until the next time I see you, take care and enjoy the rest of your day.